Hello and welcome to this lecture on Node.js and MySQL. So in coursework 3, there's 15 marks for using a database, 5 marks of which are for just getting database running and displaying some data on your website that comes from that database. And then there's 10 extra marks for data complexity. That means, multiple tables, larger amounts of data and so on. Now Node.js supports a wide variety of databases. So it works with MongoDB in the sort of classic mean technology stack, or CouchDB, or there's a bunch of sort of other ones as well. It'll work with MySQL, and it will also work with the Amazon cloud databases, for example, such as S3, DynamoDB, and so on. And in this lecture, I'm going to focus on using Node.js with MySQL. For a couple of reasons, really. I guess MySQL is sort of really popular. There's a large number of MySQL databases out there, so it's sort of very industry relevant in that sense. But also, I think it's good for you to learn an SQL database and how to use SQL, the structured query language SQL, to interact with the database. And that's the other reason I've chosen to use Node.js, to introduce you to using Node.js with MySQL. Of course, you're welcome to use a different database in coursework 3. The only database that you're not allowed to use is MongoDB, because you had a lot of experience using that already in coursework 2. So this lecture, I'm going to start by explaining, introducing you to the MySQL database, talk about how to create databases and tables in MySQL. Then I'm going to talk about the structured query language and just give you a very, very short introduction, some basic commands that you can do using SQL. And then I'm going to explain how you can use Node.js to interact with the MySQL database. Okay, so MySQL. So as I said, MySQL is popular, it's free, and in the lecture on MongoDB I talked about these kind of ACID properties that some databases have. So things like atomicity, consistency, isolation, durability. So MongoDB sort of lacks like at least one of these some of the time, whereas MySQL is one of these sort of more rigorous databases, slightly old school kind of architecture where you kind of you want all the data you have this notion of sort of valid state in which everything kind of matches up and then it moves it from one valid state to another with a transaction, all this kind of stuff. So MySQL is an ACID compliant database, which for some applications makes perfect sense. So MySQL is a great database. I did a project with it years ago. Holding data for neural network simulator, and it was like a really good solid database, and it's used extensively with web developments like the LAMP technology stack, which is like Linux, Apache, MySQL, and PHP. So obviously, large numbers of websites have been powered by MySQL, including some of the bigger ones at the earlier stages in their history. So it's free, it's high performance, people spend a lot of time making it work fast. Obviously to get the full performance you need to spend time configuring it correctly. As I said, it's widely used, it's fairly easy to use. You don't really often get something that's sort of really big iron, solid piece of technology without it having some complexity to it. But it's fairly easy to get started with. And we use the structured query language to interact with MySQL, which is kind of an advantage. And there's many supporting tools, so there's tons of graphical tools, for example, and probably a bunch of other tools for doing this and that with MySQL databases. Now, I don't fully understand the whole political or legal reasons, but for some reason, the MariaDB project was started as a fork of MySQL in 2009. So originally MySQL was sort of entirely open source or whatever, and then something I think was maybe bought by Oracle, so they started this other project, MariaDB, based on the source code in 2009, and they're kind of continuing to develop that kind of in parallel MySQL. And so you can download the MariaDB if you've got disinclinations against Oracle, which maybe still owns MySQL, I'm not sure. And MariaDB is the version of MySQL that comes with XAMPP. So the main reason I'm explaining this to you is if you launch up the console of the XAMPP version of MySQL, it's going to say welcome to MariaDB. So don't get confused by that. It's basically the same as MySQL. The MySQL is a piece of software, so it's often called a database, like the MySQL database, but it's not actually a database, it's actually a piece of software called a Relational Database Management System, which is RDBMS. So this software is used to manage the database, and the software is also used to is capable of communicating with other pieces of software running on the local computer or computer millions, thousands of miles away. So you start up the software. The software then will manage files on the computer. These files on the computer contain database, and this software will listen on a particular port, 3306 by default in XAMPP, for commands. And then other programs such as PHP or JavaScript will have a driver, and the driver will know how to establish a network connection to port 3306, and then it will send these SQL commands to the database and receive data back from the database in appropriate format. So yeah, MySQL is a piece of software, not the database itself. Database is kind of contained within the files on the computer system. So if you want to use MySQL instead of MariaDB, I said they're pretty much equivalent, then you can download and install the community server is what you want. There's various, they try and push you to, buy the sort of MySQL commercial edition, so on and so forth. But if you drill down through it, you can actually find the MySQL community server, and that's the one that's free and a fully featured free version of MySQL. Now in this lecture, I'm going to explain how you can use the MySQL that's packaged with XAMPP. It doesn't really make much difference, but since I've already shown you got XAMPP, I've already got the portable version of MySQL running on XAMPP, potentially on your USB sticks if you're using the lab machines. So I'm going to focus on the MySQL that's packaged with XAMPP, but it's pretty much the same. As long as you've started, whether you're on Mac or Windows or whatever, you should be able to start up MySQL and have it running and listening on that particular port. And it doesn't matter whether you're using Node or whether you're using PHP on XAMPP or PHP, using the independent PHP server. As long as there's a driver that will enable the software that you're running for your web server should still be able to talk to the MySQL on that particular port. This is like it's using a network connection. So within XAMPP, we start the MySQL software running by clicking Start in the XAMPP control panel. And you'll see that change to Stop, just the same as when you're running Apache, and you should see the port MySQL is listening on. So here's the XAMPP control panel. Here we have the MySQL part of it, and all we do is click Start, dead easy, and then it should turn to Stop, and it'll give us the ports and the process IDs or whatever, and it'll tell us that the status change detected is running. So it's as easy as that. Just get the version of download. If you're using Windows on lab machine, just download the portable XAMPP, open up the control panel, click on Start, and MySQL should just start. It's that easy. Now the first thing you need to do as MySQL is sort out a user account that you're going to use for your web server. So typically MySQL ships with a root account that does not have a password. So generally you don't want to have something listening on your computer that's completely unsecure. So obviously you need to fix this. I've also got a hunch, but it's only a hunch, that you're going to have problems like configuring the database until you've actually set up the appropriate password. So in general, the sensible thing to do is to fix the root password to something sensible, and then create a separate account that has the permissions that you need to create databases and change the data, etc. Now you can do all this stuff on the command line using MySQL client, and in a sort of proper industrial setting, that's what you would do. You'd create some scripts, and these scripts could then be used to initialize the database in different environments, and so on and so forth. But let's face it, it's kind of easier to use a graphical tool to interact with MySQL, and obviously this isn't this is one lecture on MySQL, right? I can't possibly go into all the details. So in this lecture I'm going to focus on using graphical tools to interact with MySQL, to set it up, create the database and tables and so on. Now the graphical tool I picked for this lecture is HeidiSQL. I picked it because it's one of the recommended ones, and I picked it because there's a portable version, so I put a portable version on the course website. If you're using a Mac, then you can't use HeidiSQL because it's only Windows only. But I had a little look, and SQL Pro is also free and looks pretty solid, and maybe you could try that or try a different one. There's lots of kind of graphical tools for interacting with MySQL databases out there. So this is HeidiSQL. So it's basically just a graphical tool that lets you interact with MySQL, with the MySQL databases and also the MySQL relational database management system. It makes it very easy to create users, create tables, run SQL commands, etc. There's a portable version, which is one of the reasons I picked it. So if you look at the software on the course website, there's the portable HeidiSQL. And you can also download and install HeidiSQL, like like a proper installation from the HeidiSQL website. So here's the tool, and I'll be sort of doing a few things to kind of demo the different bits of functionality we need to do to get everything running as we go. So I'm not going to bother too much talking through the interface of HeidiSQL because I know some of you are using Macs anyway. So the first thing we're going to do with HeidiSQL is create a user account. So what we can do is start up our MySQL, because obviously HeidiSQL needs to talk to MySQL. Then once we've got MySQL running, we're going to launch HeidiSQL, and then we're going to connect using the default settings of root and no password, unless I've got disabled those, which I may have done already. And then we're going to create a new user account. So let's just see. So when you launch HeidiSQL, you see this session management here, and you can give your session a name, and then here you can see you've got the settings, the connection settings, and here we've got like the local host and the user root and no password field here. So we enter these details. The port's the one that this port here should match the XAMPP port, the XAMPP control panel displays that MySQL is running on. Then we click on Open, and then that takes us into HeidiSQL. Then within HeidiSQL, we click on Tools, User Manager, we click Add, we type in a username and password and give that user global privileges and click Save. So once we've got into once we've connected with the root and the empty password, we get into here and we can then launch the User Manager tool, which is what's showing here. And then we can give our new user name, like user1 or whatever, and specify whether it connects within the local computer or whether we can allow connections from outside, which certainly don't want to do right now, I don't think. And then we give it a password, and we want to allow access to global privileges. If you don't give your user global privileges, it won't be able to do much, and certainly won't be able to create databases or tables. So I recommend, since you're just starting with all this, and since it's running on localhost anyway, just to give it global privileges to make everything easier. Yeah? And then we click Save, and then that will create that new user account. So once you've created a user account, we restart HeidiSQL into the new details, and then we can then log in with our user account that has global privileges. And I also recommend you use the same method to add a secure password to the root account, because obviously you shouldn't be running SQL with a root account that's unsecured. Okay, so now I'll show you how we can actually do this. So let's go to so here's my portable USB stick, and here I've downloaded the portable version of HeidiSQL, and I also need obviously the XAMPP control panel. So let's start with that. So let's wait for this to start up. So here's my XAMPP. So as you know, it's pretty easy to start up stuff in XAMPP control panel, as long as you can see it. So we just click on Start here, and then MySQL is running, and if we wait a little bit longer, we'll see the port that it's running on. So maybe we should probably wait for that. Hopefully not indefinitely. And then we'll also start up HeidiSQL and hope for the best for the XAMPP business. Yeah, there we go. So we've got the port now, 3306. So if we open up HeidiSQL, we see we've got HeidiSQL.exe. That's the one we want to run. And as I said, so once you start HeidiSQL, it gives us this session management screen. Now I'm actually going to connect. I think my root account's actually secured now, but let's just try it. So if we just type in root and no password and click open, yeah, I've secured my root. So I'll have to connect using the user account that I created, which I think 1, 2, 3, 4, 5, maybe 6. Yeah, so I've already secured my user account, so we're just going to connect with the user account that I've already created. So if it was the first time you connected to MySQL, then it would connect with the root and no password. But since I've already connected and secured my root account, I've got to use the user account that I've set up previously. So this takes us into HeidiSQL, which for some other annoying reason is a little bit small. Now we can then go into the user management section, and I'll show you how to create a user if you haven't done so already. So we get tools, I think it is, user manager, that's it. So here we have the user manager, and now we can see that if we've got my root here, I think it's already secured with a password, so that's why I couldn't connect with that password. And if we want to create a new user, we click on add here, and we give it a username, Bob1, from host, so we could connect from some, from everywhere, but obviously we're not going to do that. And then password, whatever, 1, 2, 3, 4, 5. I'm not being very secure here. And then so we type in the Bob1 password, repeat password, and click on global privileges. And obviously we could fine tune this if we wanted. If this was like the account we were going to use for our JavaScript running on Node, we'd probably want it to be able to select, maybe delete, maybe update, but we wouldn't want it to be able to delete the whole database, for example. So we might want to tweak the global privileges, but just because this is an introduction to all this, we're just going to select global privileges and then save. And with a bit of luck, yep. Oh yeah, and there we got Bob1 localhost, and obviously it doesn't show you the password. So now we can then go back to Heidi SQL and restart it. And now we can connect with our Bob account, which is Bob1, I think. And 1, 2, 3, 4, 5, I think it was. And then we can open it. And now it's, now it's going to save as default the Bob1 one, but it doesn't really matter. And now I've connected as Bob1, and I've got the global privileges, so now I can do stuff in terms of creating databases and so on and so forth. Okay. Right, so the next stage is then to create a database that we can use for our web project, and to create some tables within that database that's going to hold the data that we need for our project. So, with MongoDB, you have the following structure. So with MongoDB, you've got a database, or one or more of these databases, right? And each database holds collections, and the collections hold documents. And the data in the MongoDB database is in fields in the documents, like fields within the JSON documents. Yeah. So MySQL works a little bit differently, but it's kind of similar. You have one or more databases. Each database holds a number of tables. So you have tables instead of collections, just like you have tables in like a Word document. And each table has like a number of rows, and it's the rows that has the data inside them in MySQL. Now with MongoDB, you had the notion of an ID that was unique to each document. And that's equivalent to the primary key in a sort of SQL database. So in a primary key, so it's something that is an identifier that's unique to each chunk of data. And as you know, MongoDB automatically creates this for you. But with MySQL, there's a primary key associated with each row in a table, so that you have some unique way in which you can sort of pick out a single piece of data. Now you can use a unique field as a primary key, so MySQL gives you more flexibility with this than with the MongoDB does typically. Which is good because it lets you sort of optimize, it lets you minimize the amount of data. So for example, if you had customers and you knew that all of the email addresses were unique, then you could use the email address as the primary key and not store an extra bit of data that represents the primary, that is the primary key for the rows in that particular table. But typically, and certainly not in your sort of coursework 3, you're not sort of super worried about optimizing the space on the hard drive, right? So it sort of makes sense to create your own primary key, such as an integer, and then you configure MySQL to automatically increase this integer when new data is added to the table. So that's the sort of easiest way to create primary keys, just to configure it such as there's an integer associated with each row in the table, and that integer is going to be unique, and when you add new data, that integer is just going to be increased. So that's what I'm going to explain here. So here we have our MySQL table. So as I said, it looks a little bit different from MongoDB document. And with MySQL, with MongoDB, there's each piece of data can be a little bit different. You can have different, keys and value sets within each document, and that's because MongoDB is a NoSQL database, whereas SQL is a SQL database, obviously, and so the data structure is much more rigid in the sense that each row has a name, address, a telephone, and email, and these exist, although they may be empty or null depending on how you configure your database. And then the primary key here, so each row here I've added a sort of primary key, the ID, but I had to do that myself, and then this is the ID here, which is an integer in this case, and it's set to auto increment, which means that when I add new data to the table, it's going to automatically generate a unique ID that's one bigger than the highest one that's already in the table. And then with MySQL, you have tables that kind of cross-link with each other using these primary keys, right? So the primary key in clients, so this would be like client ID, ID client or something, will be, will correspond or be identical to the purchase ID client, and then you can kind of set up these relationships between the different tables such that the database is said to be in a sort of valid state, that this ID actually exists in this table. And so that's again why MySQL is a more sort of rigorous, tight database management system as opposed to MongoDB. And it's not necessarily, that's not necessarily a good thing. It depends what you're using your database for, right? MongoDB is a perfectly valid database. It's just that, and that extra flexibility can be perfect, for certain applications. But for other applications, maybe you want this for much more rigid data structure to ensure that there's like a consistency between all the different tables, such that all the primary keys kind of match up and make sense. So MongoDB, we use a set of methods to interact with the database, right? We called like find, delete one, insert, and so on, and then that modified the data in the database. With MySQL, it works a little bit differently. You use instead a specially designed language called SQL to interact with the database. Now, as I'm going to say a little bit later, but I'll just mention it now, structured query language, or SQL, is a complicated language, and you can get deeply into, sort of nested queries and joins and merges and all kinds of stuff. I mean, when I was studying this stuff, we had like 12 weeks, on databases, right? And I'm trying to introduce all this stuff to you in a single lecture. So obviously, I can't go into all the details here, but I'm just going to very briefly skim over enough such that you can get started on your projects. Yeah, that's the aim here. So the first thing I'm going to skim over is the fact that you can use SQL to use databases and tables, or you can use a graphical tool to create databases and tables. Now, as I mentioned earlier, what you would typically do if we were doing things properly is create a script that sets up the databases for you, and then you can just run that script to reinitialize your database, or when you're installing the database, when you're installing your application somewhere else, you might use a script to set up the database. Here I'm just going to show you how to use a graphical tool, and as I explained earlier, I'm using HeidiSQL for this, but maybe SQL Pro or something like that would work, just probably do exactly the same kind of thing on a Mac. So to create a database with HeidiSQL, we right-click on the name of the connection. I haven't bothered naming it, so it's just called unnamed. And then we select Create New Database, and we give it a name. So it's kind of easy. So we right-click on the connection name here, or session name rather, and then Create New Database. And then that'll create a new database for us. And then to create tables, we just right-click on the database, select Create New Table, add columns, and select appropriate data types. And then we can add a primary key to it as well and set that to auto-increment. And then we save the table. So here we have so we've created our database. That's our new database here. Right-click on it, create new table, and then we can edit the table. Here we can add all the different fields we want in our table, and configure things like the primary key and auto increment. So I'll show you how to do it, which is obviously easier than trying to sort of explain it all like in language, right? So here I've got one that I've created already, but let's create a new one. So here we right click on our session to create new database, and we'll call this test2, just or demo2, whatever, it doesn't matter. Just ignore the collation, I haven't got a clue what it means, but just, it's sort of the type, the character set, something like that. Then we press OK, and then we have test2, and then we right click on create new table. So give our table a name, so we'll call this on students, let's say, and that's the name of it. We could have comments, but we're not going to bother. And then within the columns, we can then create, this is the sort of names of the fields within each record, within each row of the table, which is the columns, right? So let's create some new columns. So let's call it name. And so we give it a name, then we choose the data type. So with MongoDB, the data type's kind of automatically detected because it's like JSON, there's certain conventions for all of that. But with MySQL, we need to specify the data type, and then you need to do some hard thinking about how much data you're going to have in the table, and all this kind of stuff, because obviously some of the data types are quite rigid. So here, for example, we've got text column, which has we can have like tiny text, which has 255 characters. Now we can think, well, is the name going to be 255 characters long? Probably, but let's make it text to be on the safe side because that's got like more space, more flexibility for the name. And all of these decisions that you make are decisions about how to optimally store that data on the system so that you don't use too much of your hard drive, because obviously you've got millions of records. It's going to cost you money to store extra data, and if you've got millions of records, your choice of tiny text over text is going to make possibly a different, going to make a difference to your profitability of your business ultimately. Now we can specify whether this can be like a null or empty field, and you can even specify a default. You could like put a custom value in so that all of them get like Mr. Blogs or something as the name. Yeah. So let's add another field here, maybe address, and again, well, I'll tell you what. Let's make the name. Let's make that tiny text. Just to show you something different. Yeah, and then we'll make this varchar actually. So varchar is a text field that can be variable length up to 65,000 roughly. So that's a bit more flexible and might be a bit more sort of optimal in terms of storage or whatever. And then we'll add, now we could, for example, since this is a student record, we could use the student ID as our primary key. But to show you the auto increment stuff, I'm just going to use an ID, which is going to be an int. So again, we need to think carefully about, well, an integer, the size of an integer is up to however many millions or billions, so that's probably going to be enough. But if we were going to use, but we wouldn't want to use a tiny int for ID, because then we could only store like 255 records, right? So int makes more sense, yeah. And then we can specify default here, so we can do auto increment here. So if you select auto increment, that's going to increase automatically as it goes up. And some way I think, oh yeah, so we create an ID field. We've said there's going to be an integer, and we're going to make it increase automatically. And what we're also going to do is create a new index, which is the primary key. So we're specifying here that the ID field is the primary key for this row. So this primary key is going to be unique for each row in the table, and that will enable us to link the ID key here to other IDs, maybe orders or whatever in the other parts of the database. So I think that's pretty good. We've got our name, address, and ID, and now we've created our table. So now we click on save. Yeah. So there we have it. We have our test2 database and our table of students. So now we've got our user account that's got privileges to access the database. We've used that user account to create a database and a table in this case. Now we want to use SQL to interact with that data in our database. So we can use SQL to insert data, select data, update data, delete data, and so on and so forth. So as I mentioned before, SQL is complex. People, you're going to get paid just to write SQL queries, right, as their job. It takes a long time to learn to do it well, and it gets a bit mind-bending when you get into like multiple nested queries with merging and joining and so on and so forth. So obviously, there's no time at all to introduce that. Or the other thing you learn in database courses is how to sort of optimize the data in your database. So you have these sort of first normal form, second normal form, so on and so forth, because it's very important to avoid duplication in your database and you want to make your database optimal from the point of view of the task that you're trying to do with it as well. None of that's going to be covered here. This is only a very short introduction. And to take you on to the next step, I recommend you follow a couple of tutorials and experiment with different commands using Heidi SQL. So I'll introduce it to you here, but really you're going to have to spend a bit of time getting familiar with SQL and teaching it yourself. And this is coursework 3. This is for people who want to get a 210 first. So I'm kind of fine with leaving you a space to learn this stuff by yourself. So first command I'm going to mention is insert into, and this inserts data into a specified table. So there's two ways we can use insert into. We can use insert into table, and we'll specify the table name, and then we can specify the columns here, and then we have values here, value 1, value 2, value 3. So in this case, when I'm using this form of insert into, value 1 will get put in column 1, value 2 will go into column 2, value 3 go into column 3. Or if the data is in the same order as the columns and there's no sort of columns missing, then we can just use insert into table name and do value 1, value 2, value 3, and it will put these pieces of data into the corresponding columns in the order in which the columns exist, kind of thing like name, address, and ID in the example I gave you. So here we have the employees table. So just to sort of show you, so I created my student table, but the one I'm going to actually show you here is my website employees. So here we have this is the one I created earlier, so to speak. Here we have a bunch of employees who have a name, address, telephone number, email, and a unique ID. So I set it up in exactly the same way as the student one, but it just has slightly different data in it. So here we have an insert statement. So here we have our employees table, the one I just explained to you. Then we run insert into employees. So in this case, I'm specifying the columns. So I'm saying that email, telephone, name, and address are the columns I'm going to insert. And this is specifying that this is the email, this is the telephone number, this is the name, and this is the address. You can see that email, telephone, name, and address are in a different order from the order of the columns here. So if I didn't specify these, then d@g.com would go into name, this would go into address, this would go into telephone, this would go into email, and this would create problems because this is like an integer. I think it's all text actually, so it wouldn't make that much difference. But obviously it'd be the wrong data would be in the wrong column, so it'd be a bit of a mess. So it's safer to specify the columns unless you're really sure that this is in exactly the right order corresponding to the order of the columns. So once we've run this statement on the database, then we can see that the employees table has the new data. So here's the row that we've just inserted with that statement. Okay, so let's have a little demo. So let's go back to, so this is my employees data here. And let's, nice thing about Heidi SQL, any of these graphical tools, we can actually still run queries, SQL queries on the data, on the database and see what happens. So here we have insert into, what do I call it, employees. So by convention, the sort of SQL commands are all in capitals, so that probably doesn't make any difference. And then let's specify the values. So let's do name, address, name, telephone, email. Just do a separate one, and then values. So address, I don't know, 3 Example Road. Can't be bothered with any of this really. So name, John Jones. Telephone, I think, blah, blah, blah. And email, J. And obviously we should do some proper validation all this. Jones.com, but we're not going to be just an example. And SQL statements end with a semicolon when you're typing them in the command line. So semicolon there. And then we want to run the statement. So let me just press that. And if you look at the bottom of Heidi SQL, you can see that all of the SQL statements being run on the database. It says effective rows 1, blah, 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 blah. If we go back to our employees table, the data here, and click refresh, then we can see that we've got John Jones here, 3 Example Road, telephone, email. So all the data's gone into the correct columns because we've specified the columns where the data should go. That's pretty easy. So next one I'm going to mention is select. So we put some data in the database. Now we want to select a sort of subset of that data, or maybe all the database, all the data. So the way we should do that is select. Then we specify the columns that we want to select, and then we use from table name. So obviously we want to select, name and address or whatever from a particular table. We can select all of the values just by selecting star from table name. That's sort of handy sometimes, but more often we're going to want to select a specific piece of data or a range of or number of pieces of data rather than just selecting everything. So here we do select column 1, column 2, or select star from table name, and then we use the where condition, and the where condition will limit the number of rows that are actually returned. So it's a bit like with MongoDB, you have find. You can just run find with kind of empty braces, and it will return everything in the collection. Or you can specify a search condition within, as a JSON document that will limit the number of rows that are returned. So here we have the employees table, and we're going to run a select name and email from employees, where email equals d@g.com or name equals Carol Smith. So you can use kind of Boolean conditions and or not and so on and so forth. To specify kind of relationships between different bits of data or whatever. So here, as I said, I haven't got time to go into all of this, but here we're doing So we're either going to find rows where the email is equal to d@g.com or the name equals Carol Smith. And again, SQL also, you can search inside, for sort of more sort of detailed querying. I could set up a query looking for addresses that contain Mossy, for example, and so on and so forth, or addresses in London, and there's lots of ways of breaking this down. Then we get the results. So here we have the name and the email. There's the columns I want to return, and in this case, there's one that has d@g.com and one that has carol@net.com. So I'll do another little demo. So here we are, back to my employees table. So let's kill this. So we can let's do select all from employees where, let's find a condition that sort of looks silly tempting. Name equals David, for example. Yep. Okay, and we'll run that. And you can see here the results. You have the name, David, so we select all the things, but we can also select the address, and in which case we're going to get just the address of the employees where name equals David. Then we've got update, where we're modifying data in a table. So we're having update table, we're setting we're changing the values here. We're saying that this column has to have this value, this column has to have this value, and then we have where condition. Again, we're specifying a condition that controls which of the rows we're actually updating. So here we have the employees table. We do update employees. We want to set the telephone equals 123.6, where name equals Carol Smith. So here we have the name. The telephone number is currently 546-544. And then we have 1, 2, 3, 4, 5, 6. So obviously this is a bad example because there might be several employees called Carol Smith living in different parts of the country or whatever. And in this case we'd be updating all of their telephone numbers, which would be really bad. So in this case we'd probably be better off finding a unique, the particular ID of the employer and using that as our condition or our update statement. So I'll just show you that now. So let's update Adam Abel. We'll change Adam Abel's email address, let's say. Set email equal to hello Adam at example.com where ID equals 10. So it's currently Adam at able.com. We're going to change that to Adam at example.com if this works. ID equals 10. So if we run that, so effective row is 1, that looks good. So now Adam at able.com, if we refresh this, we've now got Adam at example.com. So it's much better to use the ID and then pick out a unique, especially if we're doing things like with the customers logged in or something, then we know their ID and we can use that to tightly control the data that we're updating. Okay, then we've got delete statements, also handy. So we have, which deletes the rows matching the specified conditions. So we have delete from table name, where condition, whatever. You must be very careful with this because if you omit the where, it would just delete from table name, would just delete everything in the table, and that's not often convenient. So you have the employees table, so Adam Abel, blah, blah, blah. If we do delete from my employees where email equals wendy@mail.com, so it's picking out all the rows where the email is wendy@mail.com and deleting them, and you can see that the Wendy Adams row has been deleted from the table and no longer exists down here. So let's do a final demo of this. So here we go. Which one should we delete? Let's delete John Jones. It's ID equals 16. Where I think that's right. So run that. So here are our data. We refresh our data. you can see that the John Jones record's disappeared. Okay, so in the last part of this talk, I'm going to now explain, so I've talked about how MySQL works. Now finally, I just need to show you how Node.js works with MySQL, and then we've kind of completed the journey of this lecture. Yeah. So first thing you need to do is set up Node.js with the MySQL module, so that it can talk to MySQL. So this will install appropriate drivers and various libraries, whatever is needed, so that Node.js can communicate with the database. So you change so there's two ways, as I explained in the previous lecture on Node. There's two ways of installing modules within Node. So if you have the portable version of Node, you install kind of globally within the portable version. So that's how the portable version works, and I've already done this for you in the portable version, so you don't need to do install MySQL in the portable version. If you're running, if you've installed Node separately on your computer, which is probably the easiest way to do it if you've got your own laptop or desktop, then you create a folder. The folder contains your application, and then you install MySQL as a sort of module within your application. And to do that, you change to the root of your application, type npm node package manager, install MySQL to add the MySQL module to a project. So it's very easy. With a bit of luck, it'll just work, and then you can use the MySQL module within your JavaScript running on Node. So the first thing we need to do is to connect to the database, and we do this in the following way. So firstly, we do MySQL require. So this is sort of getting a hold of a variable that is obtained from the MySQL module, and this variable, JavaScript variable here or object, will let us do different things with MySQL. Then we use this MySQL object has a method create connection. So here we specify all of the details of the user account that we created, that I explained how you could create in the earlier part of the lecture. So we've got DAG1356, and specified database we want to connect to here, and host. Obviously databases can run on separate machines, so this might have an IP address here, but if this is what I've set up in the earlier part of the lecture. And then it's very easy. This creates the connection. We do connection.connect, and then connect has as an argument a function that's called when the connection takes place. And this function has an error argument, so you can check the error argument for error messages. And if it all works well, then you can log, connected, and do some other stuff if you want. Now, just like MongoDB, MySQL has a limited number of connections that can be open at any given time. So it's a good idea to kind of close the connection when you finish doing whatever you're doing to the database. Now, if this was a more commercial application, actually running on a real web server, you wouldn't close the connection here. You'd have what's called a kind of connection pool. You'd have like maybe 5 connections, and then as new HTTP requests came in, they'd sort of utilize one of the available connections in the connection pool, or maybe you have to queue for it or something. So this isn't what you do with a commercial website, but I think it's probably the easiest and safest way to kind of handle it on a sort of, on a student project, shall we say. Otherwise, your Node.js application won't end. It'll just sort of sit there waiting in WebStorm, and potentially also you'll have a problem that you'll run out of connections to the database, and then nothing will work and you'll just be in a bit of a mess. So I strongly recommend you actually close the connection each time, and then that's simple, and it'll work for your projects. Okay, so it's a little demo. So here we have. So let's just stop MySQL just to show you an unsuccessful connection. Okay, so MySQL is not running here. So here's within WebStorm, we've got the code I just showed you. We're getting this MySQL object, setting up the connection. That should work, I think. And displaying the error message, so on and so forth. So if you just run this, then we get all this stuff. Let's throw an exception, and it says, error, connection refused, and so on and so forth. And that's obviously because you haven't got the MySQL database running. So now if we get the database running, and now we try and connect, and we get connect. I don't know why it's saying not rows delete. Oh, it's running the wrong one, sorry. It's running delete, so let's run MySQL. MySQL connect is what I want to run. Oh yeah, it had a different name. WebStorm's a bit confused. Anyway, when we run this file, we just get this connected output here, okay? Because it's connected. So easy peasy. Let's move on to doing some slightly more advanced stuff. So once we've connected to the database, we can then build SQL queries and execute them on the database. So everything I explained in the previous section, we can now do within Node. So we can do things like insert data, select data, update data, and delete data. And as I keep emphasizing, SQL is complicated. It's really a 12-week course with lots of labs and modules. It's not something I can cover in a single lecture. I'm just getting you started here. You're going to have to spend SQL. You're going to have to spend time learning SQL on your own. So insert data. So in all these examples, there's the kind of connection code and the disconnection code. So this stuff here and this stuff here. And then in between that, we've got the sort of unique bit relevant to our example here. So in this case, the insert data. So for the subsequent examples, I'm just going to show you the bits that are different. I'm not going to bother showing you this each time because it's limited screen space and all that. So to insert data, what we do is we build an SQL query, just like the ones I gave you as examples in the previous section, only you don't need the semicolon at the end of these, and they're being executed by Node, by JavaScript. So build an SQL query, it looks a bit like that. So insert into employees, again, just like I explained in the previous section. Then we have this con.connection.query, which will execute that SQL on the database. And when that SQL is executed, it will call this function, which has like an error sort of argument here, which will have information about any error. And then if we have a result, if we're getting data from the database, the result here will contain the data from the database. Or if we're modifying the database, it'll tell us, we can use this result object to tell us how many rows are affected, and maybe an insert ID if it was inserting data into the database. And so it'll call this function, and then we can log or check or whatever the details of the result field if we're inserting data, or we can actually extract the data if that's what we wanted to do. Okay, so that's our insert. Let's just do a little demo. So here we have our up-to-date database here. Animable, blah, 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 blah. Now let's go back to insert here. Let's got the right details. So what we're going to do is insert employees. Wendy Adams, is Wendy still there? So if we look at our data, yeah, Wendy Adams is there. So, well, maybe I'll stick another one with Wendy Adams in, doesn't really matter. I don't think it's really worth modifying this example. So now if we right click on this and run MySQL insert, and it says, so we get this feedback here, we get result.affected rows, that's one row is updated here, and it'll tell us the insert ID here. So now if we do refresh, we can see that we've added another Wendy Adams at the bottom here, and it's automatically created a unique ID, and this sort of emphasizes why you need a unique ID, because if we were just trying to update rows using the email address or whatever, the email address isn't unique in this database. And we haven't if we configured it to be unique as the primary key, then that'd be fine, but since we haven't, if we were doing updates based on the email address, that could create problems for us. Okay, so we have some data in there, and we want to select it. And as you might expect, when you run a select query on the database, we get back a JavaScript object that contains an array of the objects. And each object in this array is a row from the database. Now we could wrap the results in HTML, and if we weren't building a single web page application, that might make some sense. Since we are building a single page web application, the most sensible thing to do is return them in JSON format, just as is, and then the client-side script can unpack the results and insert them into the page. And that'll make your server-side scripts much simpler and much easier. Yeah. So we have our select status statement. So here, as with all of these stuff in Node, we're just building the SQL query, we're executing that query. That query, when it's executed, we'll call this function, this anonymous function here. After checking for errors, the most sensible thing to do would be to stringify the result and return it back to the client. In this case, I'm just logging it to the console. But if we did want to work through it, we could just do result for each. Now the result for the for each statement way of working through an array is basically we do the array, this is an array here, dot for each, and for each result it will call this function, and employee here is one of the objects in the array. Yeah. So it'll call this function employee for the first piece of data in the array, the second piece of data in the array, and so on and so forth. Now the employee object is a row, and the row has an ID, a name, address, and telephone number and email. And so we can just access the data in all of the columns in the row in this very simple way using a dot notation, and we can just output them to the console. I'm not sure what we do with them otherwise. It really just makes them the most sensible thing to do in the context of your projects is to just return them as a JSON. So do a little demo. Okay, so this is what we got here. So what we want to do is run the Node script, which is select. So exactly what I just explained. So let's just run this and you'll see what it does. So this is what's actually coming out of the database here. We've got like these objects, JavaScript objects represented in JSON format with the name, the address, and so on and so forth. And this is an array, as you can see from the square brackets here. So the most sensible thing is return this to the client-side script, and it can unpack it and put it in there. Use the document object model stuff to put it into the web page. But just for clarity, I've worked through each of the results. So you can see that this is the first row in the table. This is like employees outputting the name, the ID, name, address, and telephone, email, so on. And so it's outputting the data as well on the console, just to show you what it looks like. Now, updating data, again, it should be no surprise to you. We just build the SQL query, doing what we want to do, and if we were sending some data to the script, we could then, use string concatenation to add, to build a string that had the appropriate SQL query. Then we execute that, and again, it'll tell us, we can use the result to figure out how many rows were affected and how many rows were updated and so on and so forth. So let's see this. So what we got, here's my MySQL update script. So what am I doing? I'm setting address equals 45 Turing Close Manchester, where ID equals 10. So let's just look at our data. I've already done that already. So let's just change Wendy Adams one. Let's change Wendy Adams' address. The second Wendy Adams, we'll try and change that to the Turing address as well. Maybe she's developed a new relationship with Adam Abel or something like that. So ID equals 16. Okay, so we build the query, execute the query, and output has what happened with all that. So let's run that here. And it's telling us that we're connected and we got one row updated. So now go back to Heidi SQL. So we're trying to update this row here. And if we refresh it, we can see that now Wendy Adams' address is 45 Turing Close Manchester. So we've modified that piece of data in our table. Okay, finally, I'm not sure it's such low resolution this, delete. So again, we build the query, we execute the query on the database, and we can figure out, we can use the result object to find out how many rows were affected. And, it's not, this should all be super obvious by now. So we want to delete ID equals 16, so we're going to delete the last Wendy Adams here, because it's kind of a bit duplicate anyway. So we're going to execute that query, so right click, run MySQL delete, and then it's deleted it. So with a bit of luck, when we refresh our data, we can see that the other Wendy Adams has disappeared. So this lecture, I've explained how you can build SQL queries and execute them on the database. So all this, every sort of example I've given you has kind of had this sort of thing where we're building up an SQL query and then we're executing it on the database. In many ways, it makes more sense to use what's called an object relational mapping library or framework as a middle layer between your JavaScript code and database. And this is typically what's done in industry. Within Java, there's a very popular framework called Hibernate, which uses Java objects as a sort of middle layer between the database and the actual code that uses that data. And the same thing exists within JavaScript. You can sort of build an object relational mappings, will map the rows in the table onto JavaScript objects, and so you can access the data in the table by accessing the JavaScript objects, and you can actually then, but if you change these JavaScript objects behind the scenes, the framework will update the data in the database. So it's a nice sort of middle layer and prevents sort of hacky mistakes caused by fiddling around with the SQL and is basically a more elegant and safe solution for building databases and interacting with data in databases. So here's a couple that I found for MySQL. I haven't tried them, but if you do a search for ORMs, MySQL, Node, whatever, then SQLize and Bookshelf looks like they're fairly current and up to date. So before we go into the example code, I just want to mention one thing, which I didn't include in the lecture, but it just occurred to me. If you go, so with MongoDB, I explained how you can use MongoDump to back up the data. And I'm just wondering, I'm going to very quickly check to see. So all the MySQL files are in here, and it's probably got, yeah, there we go. So with MongoDB, the best way to back up the database is to use MongoDump, right, and then Mongo Restore to put it back. And the same programs, there's equivalent programs for MySQL. You've got MySQL dump here, and then maybe a MySQL Restore, or maybe use MySQL Restore, whatever. So I strongly recommend, when you're working with your coursework 3, that you use MySQL dump to dump your database to a file, and MySQL, whatever it is, Restore or the equivalent, to put that data back into your data when if you lose your data. And I'll find a tutorial on that and put a link to that on the course website for you. So just to wrap it up, so all the example code I've showed you is available on the course website as usual, and as usual you're welcome to use this example code in your projects. It won't be super useful, but maybe the boilerplate framing stuff will be handy. There's a bunch of resources in the course website. As I said, I'll add an MySQL dump example to there as well, and hopefully these will help you get you started with Node.js and MySQL. As I said, you're going to have to spend some time learning SQL, and so there's a couple of tutorials I've given you there for that. Alright, so this lecture has explained how you can use JavaScript running on Node.js to interact with MySQL, and this is the last lecture in this module.